Alright, let's try to attempt this problem. Identify the degrees of unsaturation for each pair of compounds. So let's see. At face value, for this first pair, it seems like the degree of unsaturation du is 1 for here and here for both of these compounds. But let's prove that with the equation. So the first thing to do is to identify all of the hydrogens, whatever is actually present in the compound. So here we have an alkene, it's terminal, and at the terminal carbon, the primary carbon, we have only 2 hydrogens here. At the secondary carbon, we only have 1 hydrogen. And at this primary carbon here, we have 2 hydrogens. So that gives us a total of 5. So H equals 5. Now we need to determine that theoretical value, and that's based on the number of carbons. We can count 3 carbons here. If we double that, we get 6. Add 2, we get 8. So then, to determine du, we first plug in our theoretical 8. We then need to subtract 5. And because we have 1 halogen right here, we got to subtract 1. So all we do then, divide by 2. So 8 minus 5 is 3, minus 1 is 2. 2 over 2 is 1. So the degree of unsaturation is 1 here. Now for compound 2, it seems like we have 2 extra hydrogens because they're bound to the amine. But let's count them all up. Again, at the primary and secondary carbons, we have a total of 3. At this primary carbon, it's sp3, so it makes sense to have 2 hydrogens bound here. Bound to the nitrogen in the amine, we also have 2, right here. So the total number of hydrogens would be 7 in actuality. The theoretical value of 8 doesn't change. So going back to the equation, again, we find that theoretical value, we subtract the number of halogens, subtract the number of actual hydrogens, and we add based on how many nitrogen atoms are in the compound, again dividing by 2. So let's calculate it. For compound 2, let's bring in 8. We then subtract 7. And then we need to add 1, because we have 1 nitrogen atom. Let's divide by 2, which again gives us 2 over 2, which is 1. So what happens if we forget to add or subtract 1? Let's see. If you take 8, you subtract 7, that gives you 1. So 1 divided by 2 is half. Of course, degrees of unsaturation are all integers. They're all whole numbers, including 0. So the numerator in this case needs to equal 2, because 2 divided by 2 gives us 1, and at face value, we don't have a ring, we just have 1 pi bond, so it makes sense that the degree of unsaturation is just 1. It's the same for this compound too. If we take 8 and subtract 5, we get 3. 3 over 2 won't work, so we need to subtract 1 for every halogen present. You do that, and you get 2 over 2, which equals 1. You get a whole number. So if you find yourself getting decimals, there's probably something wrong in the equation. The numerator and denominator, when divided, must give an integer. Now let's do the second pair. Let's look at compound 3. First, what we do is determine all the number of hydrogens. These are terminal methyl groups to start, so we have 3 here and 3 here. This part of the alkene is tri-substituted, and so is this, so no hydrogens here. The secondary carbon here only has 1 hydrogen, and the terminal carbon would have 2. So if we add this up, 2 plus 1 is 3, plus 3 is 6, plus 3 is 9. And if we calculate that theoretical value based on how many carbons, well, we have a 5-carbon backbone and 1 branched methyl, that's 6. If we double 6, we get 12. Add 2, we get 14. So the procedure is the same. Let's bring in 14. We then subtract 9. And then we subtract 1 based on how many halogens. We just have 1 chlorine. So for that, we just subtract 1. Divide by 2. 14 minus 9 is 5. Minus 1 is 4. 4 over 2 is 2. We have 2 pi bonds. The degree of unsaturation is 2. Another thing is that if you're dividing by an even number, in other words, if our denominator is an even number, we need the numerator to be an even number also. If you put an odd number on the top and even on the bottom, you'll always get a fraction. So to get whole numbers, strive to form an even number on top. 14 minus 9 gives you 5. 5 over 2 yields a decimal, 2.5. So we need to subtract based on how many halogens we have, which would then give us a whole number, 2 in this case. Another consideration, if you get rid of this chlorine and just put a hydrogen here, the actual number of hydrogens becomes 10. Of course, because this chlorine is a substituent. It's substituting the position of a hydrogen. So 14 minus 10 would give us 4, and 4 over 2 gives us 2. So the idea is chlorine is substituting the position of a hydrogen. That's why we subtract. Now let's look at this compound, a little bit more complicated. First of all, same procedure, let's identify all of the hydrogens. Add them all up, 4 plus 2, that gives us 6, plus 1, that gives us 7. If we count up all the carbons, we have 6. Double that, you get 12, plus 2, that gives us 14. Immediately, if you subtract 14 from 7, you get an odd number, you get 7. So in the equation, we need to add or subtract something. Now let's look at all the hetero atoms. So here we have 1 nitrogen and 1 oxygen. Oxygen isn't part of the equation. So let's calculate. First, let's bring in 14. Let's subtract 7. And then let's add 1 for the nitrogen. We just have 1 nitrogen atom, so we just add 1. 14 minus 7 gives us 7, plus 1 gives us 8. Half of 8 is 4. But wait, if we look at this compound, we just have 3 pi bonds, 3 points of unsaturation. Why 4? Well, this brings up an important point. Ring structures constitute 1 degree of unsaturation. Let's see why. In the case of straight chain N-hexane, the degree of unsaturation here would be 0. But if we look at cyclohexane, which looks like this, all of these carbons are secondary, which means they have 2 hydrogens each. Now let's calculate du. First of all, we still have 6 carbons and we have 12 hydrogens in this case. So the equation would be 14 minus 12 divided by 2. That gives us 2 over 2, which is 1. So let's try this problem. We need to draw 3 distinct compounds that have a degree of unsaturation equal to 4 and 2. So let's start with 4. We just talked about one example, benzene, which looks like this. Benzene has 3 pi bonds in conjugation, which means it has 3 points of unsaturation regarding just the pi bonds. If you add in the ring structure, benzene actually has a degree of unsaturation equal to 4. Let's draw another one. The one thing that we haven't mentioned so far, but it's kind of been implicit, is that when you have a pi bond anywhere, it constitutes 1 degree of unsaturation. Well, it turns out in alkyne systems, the composition of the alkyne, in terms of bonds, is that you have 2 pi bonds and 1 sigma bond. That means an alkyne, in isolation, let's say ethyne, has a degree of unsaturation equal to 2. But this would be incomplete. We need 4. So let's add in a few pi bonds, like here and here. Another structure we could do is draw an 8-carbon backbone, which will look like this, and just put in 4 pi bonds. Here, 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 and here. So this structure would be valid too. Now let's try to draw these structures. du equal to 2. Let's pretend that the question said one of these structures must be a ring. So we satisfied that here. So we know this structure has a degree of unsaturation equal to 1. Just add in a pi bond like this, and now it's 2. Now another structure that comes to mind is just to draw butane and put 2 pi bonds in conjugation with one another. This is 1,3-butadiene. And lastly, how about ethyne? We have 2 pi bonds, 1 sigma bond. This also has a degree of unsaturation equal to 2.